This lesson is titled Rectangles, and we're going to apply properties of parallelograms and rectangles to determine measures of sides, diagonals, and other angles. So first, we're building on what we've been talking about, and that is quadrilaterals. That's a general term, which is a closed figure formed by four segments intersecting at their endpoints. And then next we talked about a parallelogram, which is a special quadrilateral in which opposite sides are parallel. So this side, these sides would be parallel. So that is a parallelogram. So now we're going to go to rectangle, which is another special quadrilateral. So let me scroll down a little bit. And it is a parallelogram with four right angles. So it has all the properties of parallelogram, but it has some additional ones that happen because of the four right angles. And a diagonal is still a segment joining opposite vertices. So this would be a diagonal and this would be. Okay, so now we're going to look at example 1 and look at how to name these different parts of a rectangle. So first, the vertices are just the points in the corner. So we have Q, R, S, and T. The order doesn't matter at all, but when you name the rectangle, you do not use a comma, and you go in either clockwise or counterclockwise, but I could say rectangle Q, R, S, T. And then the opposite sides are the sides across from each other. So we have side QR and TS are opposite sides, as well as QT and RS. Okay? Now the opposite angles are the angles that are across from each other. So we have angle R and T, and then we also have angle Q and angle S. Now the consecutive angles are the angles that are next to each other. So we have a few of them. If we look at Q, we have angle Q and angle R. We also have angle Q and angle T. So the ones that are next to each other, we have S and T, R and S. Those are all consecutive angles. And then the diagonals are just the line segments that connect the opposite vertices. So line segment RT and line segment QS. Okay? So next, let's look at a couple of these diagonals. And we're going to talk about the diagonal of the rectangle LMNO. So we have this diagonal as well as this one. There's a couple ways that we can compare the lengths of those. We can use the distance formula, or we could use Pythagorean theorem. We're going to use the distance formula here. So we're going to look at this point, M, and so we need to give the coordinates. So that would be 3, 4, and then N would be 3, -3. O would be -6, -3, and then L is -6, 4. Okay, so if we want to find the length of those, we can use distance formula. So let's first do MO. So it's going to be x minus x. So 3 minus a -6 is going to be 3 plus 6 squared. And then 4 minus a -3. So 4 plus 3 squared. And we will get 9 squared plus 7 squared. So the square root of 81 plus 49 becomes the square root of 130. Okay, I'm just going to leave that like that, not simplify it. And let's look at the length of, let me change the color, LN. So I'm going to do that here. So the square root of x minus x. So 3 minus a -6. So 3 plus 6 squared. plus negative 3 minus 4 squared. So I get the square root of 9 squared plus negative 7 squared, which is 81 plus 49. And if you look here and look here, you're going to see that we're also going to end up with the square root of 130. So what you can see is that the diagonals have the same measure. And that is going to be true in every rectangle. So scroll down a little bit. And the diagonals of any rectangle are going to be congruent. So now let's look at the properties of a rectangle and fill this in so we can use it over and over again. So we start with the same 5 properties of a parallelogram because they're true of a rectangle. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. So those are the 5 properties that we listed for parallelograms, and they're also true of rectangles. Now we have 2 additional properties of a rectangle. We have 4 right angles, and the diagonals are congruent. Okay, so pause if you need to and make sure that you have all of these properties. You can start using symbols if you want, and for parallel we can put 2 lines like that. We can use the symbol for congruent. Supplementary, I usually just write 180, and so maybe that's helpful. But let's scroll down now, and let's use the properties to make some equations. So we have a quadrilateral, and they tell us it's a rectangle, and they give us a length of MO, so that is a diagonal, and NP. So we go back to the property that diagonals are congruent, and so we're simply going to set 2x minus 8 equal to 23. So 2x is equal to add 8 to both sides, 31, and divide by 2, and x is equal to 15.5. Okay. A quick check, we have QS and RT. Again, those are diagonals, so you would set them equal to each other. So 3x minus 2 is equal to 48 minus 2x. I'm going to add 2x to both sides. 5x minus 2 is equal to 48. Add 2 to both sides, and we get 5x is equal to 50. And x is equal to 10. Now, in this one here, we have AC and DP. So we need to look at this one a little more carefully. Okay, we're going to go back to the property that says diagonals bisect each other. So this has to be congruent to this. So if they give us AC, that is this whole side here. But then they give us DP, only this part. But from the property that diagonals bisect each other, we know that if this is x plus 7, this part is also x plus 7. So we can add those two together and get 2x plus 14 and set that equal to the whole diagonal here, AC. 4x minus 13. And so it's an algebra problem. Subtract 2x, we get 2x minus 13 equals 14. If you add 13 to both sides, we get 27 is equal to 2x. And so x is equal to 13.5. Okay? Go ahead and pause and do the quick check yourself, please. This one is similar to the last one. They give us RZ, which is just this part right here, and then they give us TW. So RZ and SZ are congruent. So if this is 2x plus 5, we add them together, and we get 4x plus 10 is equal to TW. 5x minus 20. And then if we subtract 4x from both sides, we get x is equal to 10, and then we add 20, and we get 30 is equal to x. Let's look at example 5, RSU. Now we're talking about angles again, okay? So be careful here. We're talking about angles. And RSU, so RSU is this little part right here. And that's 3x minus 5. And then they give us UST. So UST is this angle right here. Now, a lot of people want to tell me that they're congruent. Now, they're not necessarily going to be congruent. Only if it's a square would they be congruent. But we do know that it's a rectangle, and these two angles together have to be a right angle. So we're going to add 3x minus 5 and 4x plus 4 and set it equal to 90. So we have 3x plus 4x is 7x, and then a negative 5 and a positive 4 is negative 1. So we get 7x is equal to 91, and then we divide by 7 and use my calculator. 91 divided by 7 is 13. So the last problem is this quick check. So go ahead and see if you can set it up yourself. Hopefully you saw that LMN is a right angle. It's a rectangle, so that's a right angle. So you're just going to put 11x plus 35 equal to 90. If we subtract 35, we get 55. And so x is equal to 11. All right, so those are the properties of rectangles.